Just to present myself, my name is Knut Jetlund. I'm working for the Norwegian Public Roads Administration, and I'm also working on a PhD at the Norwegian University of Science and Technology, very closely related to what we are talking about here now. I was one of the hired experts on for the standardization of the TNITS specification for the SEN work there, and my expert role was as expert of geographic standards or standards on geographic information. So I'm gonna try to take us through the principles and the model in the specification. So I prepared a presentation, and I suggest I go through this, and then we can open for questions after the presentation. If anyone want to contact me afterwards, you see my contact information at the bottom here. So just to put this into kind of a context, this is actually what I'm working on my PhD. We have on the slide here, we see 3 abbreviations for different domains. We have GIS, Geographic Information Systems, we have ITS for Intelligent Transportation Systems, and we have BIM for Building Information Modeling. All of these domains are actually considering the same real-world features, like we see on the illustration on the right there. We have a road with some railing in the middle, and when this road is constructed or when it's planned, then the features we see here kind of start to exist in the digital representation. And later it is being built, and the building information model is being used in the construction phase. And after that, we need to update the geographic information systems with the correct information now that we have changed the real world. But also what we are talking about here is the intelligent transportation systems that also need this information. Like for instance, the road here and the railing, and when we talk about this railing, it has it is of interest in all of these 3 domains, but it has different kind of characteristics that you are interested in the different domains. Like when you're constructing the railing, you want to know what type it is, so how, you know, the bolts and motors and everything. In the GIS, maybe it's more like the cartographic presentation of it, but also, for instance, how it's reflecting noise, because you want to use it for noise calculations. But then finally, for ITS, what may be most important is this a hard railing? Is it possible to cross it in an emergency situation? So we have different kind of characteristics that are important for the same real-world feature, but it's still the same real-world feature that shows up in all the 3 domains. So this is kind of what we are talking about here with the GIS and ITS, is where the TNITS specifications shows up. So looking a bit closer at how the flow of geospatial information can be for ITS. We have the GIS databases on the left here, maintained by map authorities and road authorities. And we have ITS databases for use in ITS systems on the right. And we want this information from the authorities to flow into the ITS databases, so they can be used by road users, both by cars and by pedestrians and bicyclists and everything. And this is where the TNITS specification belongs, for this authoritative information from road authorities to map providers and OEMs, so they can use the information, the authoritative information from road authorities to update their databases. Another illustration of the same or the same situation. This is from a presentation by Kees Weavers from back in 2005, actually. So what we see here is that we have authorities maintaining some, for this example, speed limits, and we want to exchange this updated speed limit to the map providers so they can send it out to finally to the in-vehicle systems. And once more, here is the data exchange here is where we find the TNITS specification. Yeah, the data chain we're talking about here, it's I'm not gonna read all of this information. You can look at it later, but it's about the static road information that we're talking about here. That means it's not static in the way that it will always be there, but it's kind of static, like a speed limit isn't changed every hour. The information from the authorities should be the most trusted source. It is the authoritative source and should be the source used in ITS systems. Then we have, sorry. Yeah. So when we start talking about the TNITS exchange specification, the background for it was the Rosetta project. And after that, we had the TNITS project that developed further developed the TNITS specification or the Rosetta specification. And then we had this project team that I was involved in that further developed it into a European technical specification that is now published as TS 1768 2018. There are three important parts in the specification. It is a conceptual specification of the data content. It is a physical exchange format in GML, and it is also a service specification. My knowledge is mostly on the two first parts. The service specification is, I'm not really an expert on that, so if you have any follow-up questions on the service specification, I may not be able to help you. I may forward the questions to other people. Okay. So once more, this is where we are. This is a figure from the original Rosetta project. What we're talking about here is that we have an information model, and we have a content specification, and we have a physical exchange format that specifies the structure for the services here. So we can exchange information from road authorities to the map providers. So what's so special about TNITS? Well, it is kind of a pilot project, or what you should call it, for combining standards from ISO TC211 and ISO TC204. We have a joint work now between the two technical committees. I'll just say that TC211 is for geographic information, while TC204 is for intelligent transport systems. We have a joint work now between the two committees looking at how standards from the two domains can be closer connected, so we can use the same principles. But what we have done in TNITS is to start combining these standards, and we are working in a domain normally using GDF, the ISO standard from TC204, but it has been produced as ISO TC211 conformant standard based on ISO 9109 application schema with implementation in the GML, Exchange Format for Geographic Information. It has services based on another ISO TC211 standard, ISO 19119. And it has location referencing based on standards from both domains, both from TC211 and from TC204. And furthermore, it's also incorporated models from two other standards or series of standards. On one side from the European specification DATEX, and on the other hand from an ISO standard for traffic signs. So it's kind of a groundbreaking project here because we have incorporated standards from several different stakeholders. So yeah, don't be scared about this figure. This is an illustration of how the standardization work in ISO TC211 is done, and it's based on what we refer to as a model-driven architecture. In model-driven architecture, we have different levels of abstraction for the models. We have some meta models at the top here that kind of describe how we create models. Then we have some abstract conceptual models that describe how do we define geometry, how do we define time, how do we define coordinate reference systems, and so on. And in the application schema level here, we have the more specific models, like we have in Europe with the Inspire models, like OGC have CityGML, and so on. And this is also where the TNITS model shows up. And the core of this figure is that by following this structure, and using UML to model these application schemas according to a set of UML modeling rules, we can apply conversion rules and derive implementation schemas from the models. And that way we have UML models that are independent of any implementation technology, while we can derive implementation schemas for different implementation technologies. Like in this illustration, we have the standardized exchange format for geographic information, GML, and we also have OWL for use in the semantic web. And we can have other implementation formats as well. So this is kind of the core of how the standardization work in ISO TC211 has been done, and this is also the principles that the TNITS specification was based on. Sorry. So talking a bit more about how we classify the real world. We can have two different ways of classifying the real world. One way is to have an open assumption, which means that there is always more information that may show up and that may deviate from the model. There is a reason why I have this figure of these black and white swans, because for many years people believed, at least in Europe, that there was only white swans, and a black swan would then break a model based on that assumption. While in a closed world assumption, the information model is complete in the given context. With the closed world assumption, we would say that there is nothing, all swans are white, and any information or a black swan showing up would break the model. While in an open world assumption, a black swan showing up will only add information to the model. And the reason I'm saying this is because the real world changes. This is an example from Norway. I'm sorry about the Norwegian text here, but what this says is that in Norway now we have speed limits at the different levels up to 110 kilometers per hour. Now we are considering to add a level of 120 kilometers an hour. If we had a very static defined model for our road database, then it would be difficult to add new values. But by having a generic model, we can have a more open world assumption, and we can keep adding this information. And this is why we created a generic model in TNITS. So the TNITS specification is a generic feature exchange model. You only exchange a feature that refers to a feature catalog. Like you exchange a feature and saying this feature is a speed limit, instead of the traditional way used in geographic information systems where you exchange a speed limit. And then you have some way of exchanging the feature catalog that you have described, and you have also, of course, a feature catalog that describes the information. So in the TNITS specification, this is implemented as the feature exchange model, where you have this generic road feature with a generic set of road feature properties. So instead of creating a class called speed limit in a model, we have created a generic class called road feature with reference to a road feature type. And this road feature type can be, for instance, a speed limit. This road feature can have a set of properties, and that property can be of some road feature property type. For instance, a maximum speed limit. And then we have a value, for instance, 90, and a unit of measure, for instance, 90, or no, sorry, kilometers per hour. So what we exchange here is a road feature with type speed limit. It has a property, road feature property, which is of type maximum speed limit, and then we have a value of 90 and a unit of measure, kilometers per hour. This is a very generic way and very flexible for exchanging information according to a more open world assumption, but also for exchanging information according to different feature catalogs, for instance, in different European states. This road feature also has location references. You can see from this figure here that where it says 1 ... that it must have some kind of location reference. So it must be related to the real world in some way. Furthermore, it can have conditions saying that this road feature is only valid under these conditions, or it's not valid under these conditions. Yeah, and I will come back to those, to location referencing and conditions. Furthermore, we have introduced external code lists in the specification, meaning that all code lists in the UML models are empty. Instead, we are referring to external code lists defined on the TNITS schema site. So instead of having a code list of road feature types in the model here, we have an external code list that describes the different possible values that you can use in as road feature types. What this does is that gives us the flexibility for extending the code lists without necessarily revising the standards. I believe Martin will talk about the process related to that later. Because if we had the code lists in the technical specification, then we would be very locked. It would be difficult to extend with a new kind of road feature. So instead, we have the external code lists with the standardized values as it was when we created the specification. But by having it this way, it's also possible to do local extensions for it. Like if Sweden wants to add a specific road sign that's not valid in or that's not defined yet in the code list, they can do that by creating their own extension to the code list. From a more technical point of view, it's also according to the UML2 specification to create models this way. Yeah, so we see here the URL for where the code lists reside. I checked it before the meeting just to make sure that this is the correct URL, and it seems to be working. Yeah, so like I said, this is the link to where the code lists reside, and we have a long list of different code lists from the model being defined there. Also, we have some Excel sheets that was the original for deriving the code list. So they are all accessible on that site. Okay. So next, location referencing. Like I said, all road features must have some kind of location referencing. We can see that in the model with this 1 ... star multiplicity here. In the Rosetta specification, location referencing was optional, but we discussed it in the work on the technical specification, and we agreed that there should be some kind of location reference for all road features. And the location reference can be of several different types. You can have a simple geometry location reference according to how geometry is specified in GIS standards. Like you can have a line string or a point or whatever. You can also use dynamic location references, which is what like here and TomTom likes to use with either Agora according to ISO 17472 or OpenLR references. And you can also have linear location references according to ISO 19148 for linear referencing. Or you can have a location by external reference, like referring to this speed limit is valid for the whole municipality of Hamar, for instance. Sorry, I'm just gonna drink. So there has been raised questions sometime, why do we have so many location referencing options? Couldn't we just have, for instance, geometry? Well, like I said, dynamic referencing is what the map providers want. Originally, we had Agora C for dynamic referencing. However, this is standardized, so we and licensed. So we added OpenLR because there is no licensing fee related to using that. So furthermore, we added linear referencing because that can be used to look up on Inspire Transport Networks links in case of unmatched dynamic references. Like if here receives a data set from Norway and finds a speed limit referring to some road section that's not in their database, they can use the Inspire Transport Network data set to identify that link and through linear referencing, because linear referencing is the location mechanism that's used in Inspire Transport Networks. And we can have location for reference to be used for general changes, like I said, for a whole country or for a whole municipality. Like Sweden introduced a new general speed limit for a couple of years ago or something, and it led to a massive amount of changes for their speed limits. And you can also use location by geometry for several purposes, but like suggested here for geofencing, that you can have a low emission zone defined by some polygon, which is something we have been testing on in Norway. Yeah, so I also talked about conditions that a road feature can be valid under or not under some certain conditions. So the condition data type consists of several subtypes that can define that this condition is valid under in some specific area, on specific lanes, under specific weather conditions, for specific road categories, for specific times, and for specific vehicles. And parts of the conditions model is something that we would like to work further on, that we weren't able to kind of make really complete in the work and in the standardization work, in particular for road category conditions and for lane conditions, where we would like or would have liked to create better and more detailed model that have a more standardized way of describing what lanes or what specific road categories does this feature relate to, or is this feature valid under. But what we did do in the work was to incorporate the validity model from DATEX 2. We see, if we look at this figure again, we see that we have some time condition describing a validity period for this condition, or for where this road feature is valid. And DATEX 2 have defined a validity model that describes the validity of some event that is provided by DATEX. So what we did was to include that model in the specification. We did some slight modifications on it. DATEX 2 is developed on similar principles as ISO TC211 standards with model-driven architecture by using UML in a standardized way. However, it's not according to ISO TC211 standards, so we had to do some slight modifications to make it valid or conform it to ISO TC211 standards. But what we also did was to create external code lists, because where DATEX have used code lists defined within the UML model, we wanted to have the code lists as external. So we created external code list for the values that were relevant to have external code list for. But other lists were not so relevant to have as external code list, like day a week is something that you can assume is quite stable. It will not change very often. Also, the number of weeks in a month is something that's quite stable, and the months of the year. So that was one model we included from DataX. Another model is the vehicle classification. If we once more look back at this conditions slide here, we can see that we have a data type for vehicle condition that says that this road feature is valid for specific vehicles. And if we go back to the vehicle model here, so what we did here was exactly the same as we did for the validity model. We imported the model from the DataX2 standard and modified it slightly to fit into ISO TIS 211 principles. And we created external code lists for the values in this model. So by using this model, you can describe in quite at a quite detailed level what kind of characteristics or what kind of vehicle these conditions apply to. So it's you can for the weight, for the length, for the fuel type, and for many different characteristics. And the third thing we included from external models was the traffic sign classification from ISO 14823, which has a dictionary of traffic signs, a standardized way of describing traffic signs. So if we look back at the generic feature model we had this road feature that can be of some type and can have some properties that can be of some type. That's the generic way of presenting it, but to be able to use the information from ISO 14823, we created another subtype of a road feature property where we enable the use of codes from the ISO 14823. And like for the DataX models, we also had to do some modifications on this standard to make it fit into the ISO TIS 211 world. So when we had this is kind of what the information looks like in the dictionary in 14823. So we have a maximum speed limit sign defined as 12,557 here, and we have different pictograms from the different states that have added their information to the dictionary. What we did was to transform this into a GML dictionary in XML format. So we see this GDD 12_557. That's the sign that we see down here. Described as maximum speed limited to the figure indicated, which is the information from here. So by referring to this URL here, you can then describe that this sign that I want to exchange information about now is actually a speed limit sign according to the ISO standard there. Okay, so that was mostly about the content or the content of the feature types and conditions. At the one level up, we have the dataset model that describes how a dataset is defined. So a dataset in TNITS is described in two ways, either as a road feature dataset, which consists of one or many road features. So once again, this is the generic road feature that can, for instance, be of type speed limit. So we have a dataset type here, and the dataset can have some metadata described according to ISO 19115, which is the ISO TS 211 standard for metadata, which is very widely used in GIS datasets. We also have another kind of dataset for feedback that I believe is described here. Yes. So this is the feedback data set here is further described in this model. I would say that the feedback model was not something we put a lot of effort into in the standardization process. This is mostly as it was in the Rosetta specification. And I think there is possibility for improving this model but to enable more flow of information two ways, so that the map providers can also provide feedback back to the road authorities. So this is a possible improvement in the future. So like I said, the TNITS specification is based on the principles of model-driven architecture from ISO TC 211. We find the TNITS specification, or the model in the TNITS specification, as an application schema according to this figure here, and with UML models created according to the UML modeling rules in ISO TS 211. Furthermore, we applied the conversion rules from ISO 19136 and 19139 and derived implementation schemas in GML. And these GML schemas are available on the TNITS schemas site. So yes, I believe that's what I was planning to present. I don't know if you should have questions now, or if Martin maybe should do his presentation first. I would suggest that Martin do his presentation.
Yeah, that would be a good thing before we open up for questions. Hopefully there will be some questions right away afterwards. Yeah, that'd be good for discussion. Do you want to present, Carmela, this presentation? It was only a few slides there.
That you sent me, or?
Yeah, that I sent you. Is that okay, or?
Or I can make a presenter, as you prefer.
Yeah, okay. I can make, if you make me a presenter, that's okay.
Sure. Have you accepted the invitation?
Yeah, let's see here.
Good. We see your screen now.
See the screen, yeah?
Yes, we do.
Oh, it's the opposite screen, but that's hopefully that's okay, yeah.
But you can, if you go here, I don't know, on the sharing your screen, which screen would you like to share? If the first one or the second?
Is that better?
Yes.
Yeah. All right. Okay, so now Knut has walked us through the specification and very well explained both the standardization in the background of the specification and some of the model that defines the specification. Yeah. When as Knut talked about how the external code list works, we can add features into the code list, which would make it available for the user. We have made a procedure to process these incoming change requests, and it's an internal guideline for us in the TNITS board and the workgroup 2, which is for the standardization and specification. If you have a request, you should report it. I mean, if you have something that you need to know or you need to add, it is something that we would like to know. Yeah. There is a couple of ways to do this, and I mean, if you do have a direct contact and communication with the TNITS workgroup 2, that's one solution. Or you can use the contact form within the TNITS website. You can also, bring this forward in a meeting within the TNITS meetings that we have in work groups. Yeah. To categorize the incoming requests, we have two different categories. As Knut said, the configuration requests are the requests that requests a change in the existing standards. So if you have some requests on how the existing standard works, this is a configuration request. It involves a more principal change in the standard, and this is something we would like to know if you have some needs here. The recycle and the cycle time for a updated standards would be within 2 to 5 years, but usually within 2 to 3 years, the SEN committees update their standards with a new draft and a new proposal for a new version of the standard. So this is something we try to log all the time. If you have some faults or some difficulties and requests on the specification, please send it in to us, and we can forward this to the new version of the standard, which is cycled every 2 to 3, 4 years. The different, the second requests category is simple feature request. I mean, this is what Knut talked about. It is actually just adding and editing features in the external code list. So this is a simple, pretty simple maneuver, which doesn't involve the change in the existing standard, only in the external code list. So we have made a quick and simple flow chart of how we proceed and take the incoming requests and process them. So with an incoming request, we process this within the workgroup 2 and decide if this is a configuration request or a feature request, as described earlier here. If it's we usually, if it's a request that needs to be brought up in a bigger escalated into a bigger scale, we discuss this in the TNITS board. Yeah. If it's a simple feature request, it can be easily added into the external code list. If it's a configuration request, it will be put in the backlog and logged as a something that will be requested in a new version of the existing standard. It can be requested, modified in a new work proposal, which will be proceeded, as I said, within 2 to 3 years. This is a cycle that the SEN process has. For this TNITS specification, this is under TC2 278 and Workgroup 7, which is for the ITS domain. I think that was pretty much what I wanted to say about the request procedure. Do you have any questions? Knut has talked, quite detailed about the model, and I think it has been very, very good information for many, and it's good for that we recorded this, so the developers and the members can bring this back and give it to the developers, and it hopefully will be easier both for members trying to understand the specification and for the developers to implement this into a service. Any questions to what we have talked about here so far?
All quiet.
Also for the first presentation, or only for this question?
Both. For both.
Both. Yes, I have. But
Yes, please go ahead. Yes, ask your question.
good morning. Hello. Can you hear me?
Yeah, hello.
This is Stamatis from Greece, member state. How are you? Fine? I was a little delayed, but I think so most of the presentation. I have for the first presentation. Can you hear me?
Yeah, we can hear you. It's a little bit, the sound is breaking up a little bit, but we will try if you talk slow and clear, yeah?
Is it a little better now or not?
Yeah, it's better now, yeah.
Okay. Okay, for the first presentation, the first question is about the two models you presented. I mean, let's say the open and the closed. My question is, since even the closed model has, as all the models, taken feedback from the real world, wouldn't be better anyway, irrespective of if it is convenient or not, to be more trusted in the open model, meaning that real world always changes. So if it was possible to always stick to an open model, meaning taking feedback from real world, it would be always better. I don't think if it is a philosophical or a technical question. And then I have a second question. Please answer to the first one. I don't know if it is clear about the two models of open.
Yeah, well, I'm not really sure that I understood all of it, but yeah, well, what we have here is kind of in between a closed and an open world, because we have a generic approach while we have predefined values. So we are not completely open. Like more in a semantic world, semantic web world with linked data, you are completely open, where nothing is true or false unless specifically defined as true or false. Yeah, I'm not really sure if I answer your question, but the point here is that we have a generic model that you can use for basically everything that you have defined in some external code list, and you can create your own Greek version of the code list, extending with the features that are relevant for your nation, and and others can do the same thing. And you can also ask for extensions of the standardized code list. So I believe that we have kind of this in-between approach that we have is good because we have kind of standardized while still being flexible for extensions. So I don't know if that answered your question.
That means that you don't suggest or prefer one of the two models, for instance, the closed one.
No, as I said, we are kind of in between the two approaches, where we have a model. If you look strictly at using the model that's defined in the technical specification with the code lists that are defined there, then you are in a closed world. But by using the flexibility of external code lists, you open up for a more open world. But you still have to define what you want to describe.
Okay, so I learned that we should be flexible in any way. Okay, I proceed.
Flexible and standardized.
Yes, it's combination. Yes.
Yeah.
Second question is about the vehicle classification. Is there any relation to or estimation if it will be related to the SAE levels also? For instance, nowadays the vehicle levels are SA1, the conventional ones, and 2, the most modern. So is there any attribute referring to the SAE level? I'm asking about the vehicle classification you presented, the characteristics of vehicles. Is there any such a kind of parameter index, SAE level?
No, I don't think that is a part of the model. Like I said, we implemented or imported the classification model from Datex. And I don't think the SAE levels were a part of the discussion, but you're raising a very good question because that's something that's been brought up in TC204 as well. I know that what kind of information do you require for the different SAE levels? So yes, definitely. I think that's a very valid point you're making there. So that might be something that the model could be extended with in a future revision.
Anyway, we focus on nowadays conventional cars. You know, our cars, most of us are SA level 1. Most rich of us have SA level 2. So, okay, I think it could be in the future.
Yeah,
anyway,
I agree.
Anyway, our focus as a group is on our nowadays current infrastructure. So it is not mature, for instance, yet. Okay, thank you very much. Thank you.
I have a few questions, if you don't mind. I really like the idea about the external code lists, but I'm trying to figure out how any implementations have to check the dependencies. Your external code list might change. So if we're delivering data, when would be a good time to check the code lists for validity of values? We might assume that the code list only get added to, so no values ever get deleted, but that I didn't find that anywhere in the specifications. So if that's true, then we don't really have an issue. But if values are could disappear, then when I'm delivering data, I don't want to be delivering any data that has a value that's not valid anymore. So I have to, we have to make a mapping. We have speed limits, and that's one kind of feature type, for example. What if in any event the code list doesn't support the feature type speed limit anymore? Can I still deliver the data, or do you see what I'm getting at?
Yeah, I see it.
Because you're not working.
That's very good question too.
How are you going to manage changes?
Yeah, I don't know. Maybe Martin can answer about the frequency of updates of the code lists. I believe that I don't think it's written anywhere, but I strongly support thought that nothing should be deleted from the code lists because it would kind of break backwards compatibility. But when to check the validity of your information related to the code lists, I don't know. Maybe Martin, do you have any thoughts about that?
I think it's a good question. I think if you have a request to an external code list, it's about having a dialogue when the availability of the new feature is put into system and being updated. Yeah, so it needs to be logged certainly, and you have a dialogue with the one that has the user initiative. Does that answer some of the question? And I totally agree with Knut that deleting some features from the list is not a good idea, because then you break backward compatibility.
Yeah, sure. But I'm trying to figure out, still trying to figure out, you're talking about a dynamic model, and how dynamic do you want it to be? So we're gonna create an implementation that's going to push data, and how dynamic do you want that to be? Does it automatically have to pick up new values, or are we gonna change the implementation or change the mapping? Or I'm trying to get a feeling for how dynamic the data delivery should be.
Yeah, good question. I mean, what we have so far, we have only pretty much received corrigatives or corrections of the existing standards, and trying to make some corrections on the actually delivered standards. But you're talking about how dynamic this delivery should be. I mean, if a request comes in, how dynamic should the actual processing of this be before it's available and possible to use? Yeah, maybe through this flow of procedure, it is not as dynamic as you maybe want it. Yeah.
Yeah, I get it.
Yeah, I think it's it shouldn't be fully dynamic. It should follow some kind of frequency, and probably when none of this information is really dynamic, it's always some process behind. You don't suddenly, it doesn't suddenly pop up a new kind of traffic sign. It is some process behind it. So I think we can have some kind of frequency related to it.
Yeah. No, but I'm a bit, well, afraid, it's not really the good term, but let's stick to that. All the members are gonna have different stages of implementation. Some is using the newest code list, and one is using an older version. And how are we going to manage that we're still be able to call it a standard in a few years?
Yeah.
have their own additions to the code list. How are we going to prevent that everyone only uses their own additions?
Yeah, well, in the implementation, you refer to with an URL to the code list value, and I believe that most implementations should mainly refer to the standardized code lists maintained by TNITS, and then more. In addition, some states may want to have special road signs or something, and only those should be referred to from kind of more local code lists. And you will see that from the URL that they are to another main site. I think that by following that approach, I think it would be pretty stable. I don't think we will experience the situation where different states have complete versions of code lists, or at least we shouldn't experience that situation, because everyone should use the standardized code lists as far as possible.
Yeah, I'm hearing a lot of shoot.
Yeah, of course. I'm not in a position to decide that. So.
It wouldn't be a bad idea if we have a strict rule: code lists never get any values deleted. It's not a should. It's just perhaps if you bring out a new version of the standard, then maybe you can change values. But normally, I don't want to be having to build an implementation that has to check every time. Hey, do I still have speed limits? Am I still allowed to deliver speed limits? Or it was first there was a code list saying it's a speed limit, and now it's all right, something similar but not quite the same. So yeah. I have to create new map.
I agree. I think that should be once again should be a part of these procedures that Martin is referring to.
Some principles around how this should be maintained as a framework.
Yeah, or maybe shall be maintained.
Yeah, it's a very good question.
Okay, and then I have one other question regarding the OpenLR standards. I'm not sure if anyone has any experience with the OpenLR. But in my opinion, there isn't much experience. So I'm not sure how good it's going to be working, especially if we don't standardize little things within the OpenLR standards. To be more specific, OpenLR contains a functional road class, and the standard only says it's a value ranging from 1 to, I don't know, 7. 1 being an important road and 7 being, I don't know, some gravel or dirt road. But there's nothing in the specification that says this kind of road is type 4. So if everyone starts numbering their road classes differently, then we won't have a very working standard.
Yeah, that's also a good issue you bring up there, because that is actually the situation we have, that every nation has its own classification of roads. Yeah, if you cross the border between Norway and Sweden, you will see that one road has one functional road class in Norway and another functional road class in Sweden, even though in reality it looks like it's the same kind of road. So that is that's it's a real challenge, but I also think it's challenging to define common European rules for what what kind of roads should be in the different road classes. I think Inspire has tried to create some classifications of it in the transport networks dataset.
If there is some classification, I think we should use it. If the standard doesn't provide any values, then I suggest we do, because otherwise it won't work.
Hi, it's Tom here. I can maybe explain how it's used at our side, the OpenLR road classification, in the sense of location reference. It's actually to distinguish if you have nearby roads. So you could imagine a motorway and then parallel running a dirt road or very low road class to distinguish those two roads. So the real details of the specification on road classification is not so much used by us. It's used to distinguish those really nearby situations.
Sure, but any technical implementation that's going to try to find which road you're referring to is going to need a reference. And if the map you're applying it to has a functional road class of 2, and the OpenLR code talks about a functional road class of 7, then your implementation is not going to find the parallel road.
No, but it's only to distinguish if there is really a big difference, because you also have other information in the OpenLR which is used to locate yourself. It's not done only from this information. And also said, I think the Inspire classification will do the purpose. Yeah, that's my view.
Yeah, sure, but any implementation created, even the one the classes TomTom provides, they are limited to the flexibility depending on the functional road class. So if your functional road class deviates too much, it just won't find a match.
That's true. If it deviates a lot, but not if it deviates 1 or 2 classes. No.
If it deviates 1 or 2 classes, then it will find it. But if we deviate too much, it won't find it. So the percentage of matches depends on how well we define which roads are which functional road classes. The better, the tighter we specify the functional road classes, the better the match will be.
If I can contribute to this discussion about road infrastructure types, you are right that till now it's a rather virgin area in ITS. There is not such a common accepted infrastructure scheme as far as roads. For instance, USA, that is a little ahead of us, makes this mapping according to the vehicles types. Whereas us, as European, I represent Inframix also. Inframix is a project of European Commission that we have prepared a first book chapter about different type levels of road infrastructure. Not 1 to 7, but 1 to 5, A to E, and referring mostly to highways, not to urban or not to rural. But yes, our colleague is right that we don't have yet a concrete result about road infrastructure classification. We try to implement it as Inframix, and I agree with him that it is indeed an issue that should or not should, could create or might create some problems in our work. So we, not you, we, all of us, we should still working on that, on having a common, let's say, classification. Although there are arguments from the other side, from the opposite side, for other reasons, if actually it is good to have all the European countries the same classification. But this is a long discussion. But I agree with you that it's an issue we have to handle. Yes. Anyway, your presentations were very good and accurate.
Any more questions? There's a very good questions coming forward, so it's good for discussion.
From my side, I have a few, but they're more high level, not very technical. So it's more on management and really high level.
But you are the manager.
Yeah. So I just wanted to check with all the people at the member states using the code list that Knut showed, both for the code list and for the schemes. If you've been using them, if they work, because I've seen it's on TNITS website, but I'm not 100% sure of who's maintaining those. So have you had any issue in accessing them? Have you used them?
Who has started the pilot, for instance?
I think it's Hungary and Cyprus. So it's all. So it's all right. They're all. The standards.
Not the
no, sorry. The links, the code list and the schemas. They're all. Everything is in place. Good.
The only thing in the code list, there are two Excel files. The one is 20 in the code list.
Okay.
There are two Excel files with the code list.
Okay.
So I guess the oldest one is the newest one. I don't know why you will keep the old one still.
It probably could be taken away and put in some historical folder here, so it's not confused.
Yeah, it should be only one.
Yeah.
But anyway, it's the XML files that are the authoritative files. So the Excel files are only there for if anyone can get any extra information from them.
Yeah.
So the code lists are actually derived from the Excel files, but it's the code lists or the XML files that are the authoritative source.
Okay, so by linking back to the question on the list maintenance, so if we erase or take away the oldest file, that's still fine, right? There will not be an issue. Good. And then I have another question, which is more for people who are not technical like myself. So yeah, I struggled in certain points to follow, but could we maybe have like a definition of what's the TNITS specification, then what's the TNITS feature, what's a TNITS code list with or what's a TNITS schemas. So it would be very 2 lines definition for people who are less technical and that do not understand what's what. Would that be possible for you, Knut and Martin?
Yeah, sure. That's possible to make and put somewhere that's it's possible to view for anybody who is interested. Yeah. A small description of those principal titles and features and what you describe, schemas and stuff.
Yeah, because what I can imagine is that you have technical people in the member states, and then you have project managers and the chief decision makers that do not know what they're talking about, what we are talking about. So
that will be very useful.
Exactly, that could be very useful, at least to have a blueprint.
Yes.
Yes.
for
even
kind of
technical
bridges.
technical managers
Yes.
do not know the
Yes,
details.
yes.
So
yes,
even
of
for
course.
them will be
Yes,
used. I
yes.
mean, the high
Those
level
kinds of
managers.
bridges are very important. It was thanks to bring this issue because it's very important. It's one of the issues that I was bringing in my shopping list.
Yeah, but we had those comments also from other member states,
Yes.
because sometimes in all organizations you have different type of expertise, and people don't understand each other.
Yeah. Especially when we are almost getting to a phase that is critical, you know. It's very important to have those bridges to connecting all the different teams, you know, and putting all of them at least in the same high level stage.
Okay.
I think, Knut, that all these things, you know, schemas and all this is described in the as a small dictionary in the specification document, I think. But I mean, that's not very accessible for everybody. So making a small mini dictionary for high-level specification titles and words would be a good idea.
Yeah, I agree. So it should be probably put up on TNITS website.
Yeah.
Yeah. And then another question for Knut, because I've seen your presentation is very nice, and I've seen that you quoted some sources, like some documents or something that was published by you as well. Could maybe we have those sources, like if the articles, I can remember one was an article in a journal published this year. If we can have a copy of that, of those, to keep them on our website for reference, that would be useful for us if possible.
Yeah, sure. The articles are open access, so that's not a problem. I can email you the links to the articles.
That would be great. So then we can have them on the TNITS website.
But please, when this kind of documentation will be uploaded in our site, in the TNITS Go site, please inform us, because not every one of us is going to the site all day.
I can imagine.
It's so important.
Okay.
No, but sometimes we reach a digital way of being that, well, it's in the site. But
Sure, I will circulate the
it
information.
appears to be a small detail, but sometimes.
And my last question, so sorry, I was going through my notes. Last question is for Martin. For the change request procedure, you say going through the working group 2 or contacting the contact point, the form on our website. Do you think would be useful to have a dedicated link on our website to see if you wish to suggest any change requests?
Yeah, definitely. I was actually thinking about contacting you before the meeting here, but I didn't get that far. Yeah, something that I would suggest as well, because it's a more formal communication route, channel. Definitely.
So,
Good